organic compounds are named completely differently than inorganic compounds. And so first you need to identify that the compound you're naming is an organic compound, and then you need to follow the correct rules. We're going to start by today just looking at simple alkanes. All right, the name of each alkane has three different parts: a prefix, a parent chain, and a suffix. Let's start with the suffix. For naming alkanes, they all end in ane, like alkane does. The parent chain tells the length of the longest carbon chain. The longest carbon chain in the compound is defined as the parent chain. And then finally, the prefix is used to identify branches off of the parent chain. And this is all for the carbons. We don't care about the hydrogens. We assume that you're just going to know that you should put hydrogens in wherever they're needed to give those carbons complete octets. So the prefix is going to give the location of the branch as well as the length of the branch. All right, this might seem pretty confusing right now, so let's go through this stepwise. All right, the first thing you want to do when you have an organic compound, and what I've done here is I've drawn the same alkane two different ways. So you need to start to get really familiar with using these structural diagrams, and we're going to start, however, by using the other notation. This is a condensed notation. So I've included the hydrogens, but like I said, we're going to completely ignore the hydrogens when naming. So I've just stuck them in next to the carbons, and we're pretty much going to ignore them. All we really need to know is the carbon chain. So we could name this based on this structural diagram or on this condensed drawing. Either of those, we ought to end up with the same name. We'd better end up with the same name. So the first thing you have to do is identify the parent chain. And the parent chain does not necessarily run straight. So sometimes you have to try and count a few different ways to make sure that you truly have the longest chain. So in this case, we've got one carbon up here, 2, 3, 4, 5, 6. All right, so, and I like to circle the parent chain to help identify it. And now we need to think about, could there be any way to get a longer chain? Well, we could, for example, do this, and that's 1, 2, 3, 4, 5, 6. That's the same length. So actually, we could use either of those as parent chains, and you know what? We would end up with the same name. So in this case, that would be fine. All right, so we've got our parent chain, and it's got 6 carbons in it. So we know that we need to go to our prefix here, and this doesn't have the numbers with it. 4, 5, 6, 7, 8, 9, 10. And these directions I'm giving you follow directly from your books, so you can always go and see that. 6 is hex, and we said it's always ane for an alkane. So the name of the parent chain is hexane. But we've still got some side groups, so let's go on to the next step. Right, in the next step, we need to identify each branch and name it with the prefix that defines the number of carbon atoms in the branch. And then append a YL to the prefix. All right, so what are our branches? We have a branch here, and we have a branch here, and we have a branch here. So we've got one methyl group. So meth is 1, and we add a YL to that. We've got a second methyl group. And then this group here with 2 carbons is going to be an ethyl group. And overall, we still say that this is a hexane because there's 6 in the parent chain. Okay, we've done that. Let's go to the next step because somehow we need to identify where these side groups are. It's not 2 methyl groups anywhere. They're in a particular location. Now we need to number the carbon atoms in the parent chain so the branches have the lowest possible number. All right, so we're going to take our carbon chain here in green and we're going to assign each carbon a number in order. So we could start from this side or we could start from this side. But the rule is we want the numbers of the side chains to come off the lowest. We want the side chains to come off the lowest carbon numbers possible. So obviously we're going to need to start up here. So we're going to call this the first carbon, the second carbon, third, fourth, fifth, and sixth. Now this changes our branch names, whereas before we just had, we have a methyl, and an ethyl. Now we have a 2-methyl, 2-methyl, and 4-ethyl. All right, so we numbered our carbons in the main chain, and we say which carbon that branch comes off of. And we put a dash between the number and the word. All right, now we need to start to put this together. Okay, so we've got 2 methyl groups here, and our next step tells us that if the same group is attached more than once to the parent chain, we use prefixes, di, tri, tetra, and so forth, to indicate the number of groups present. All right, so here are the prefixes we use for that. Notice that's different than the prefixes such as methyl, ethyl, propyl, butyl. These are the standard prefixes that you probably know from math class. So what does this mean? This means we take our 2 methyl groups here and we change this to 2, 2 dash dimethyl. All right, so there's a few things that you should notice here. There is a comma between the numbers. Even though both methyl groups are on the same carbon, we write the number twice. We don't just write 2-dimethyl. If it's a dimethyl, there's got to be 2 numbers. If it's a trimethyl, there's 3 numbers. So there's a comma in between, and remember we put a dash between a number and a word. So 2,2-dimethyl. Good, now we're ready to run them together. All right, and let me put, we said that the main chain was a hexane. If more than 1 different groups are attached to the parent chain, they are named, sorry, I wrote that wrong. They should be named in alphabetical order. So ethyl always comes before methyl. We're going to ignore that prefix we just added and not consider that when alphabetizing. All right, so we said that this was a 2, 2-dimethyl. So we've got a methyl group and an ethyl group. Obviously, the ethyl group alphabetically goes first. So now to put this together into the correct name for this molecule, we just run everything together. 4-ethyl, because that's the first alphabetically. And now we've got a word going into a number, so we're going to put a dash, then 2, 2-dimethyl, and then the parent name, but there's no dash, no comma, we just run it together, hexane. So the name of this molecule is 4-ethyl 2,2-dimethylhexane. It looks incredibly complex, but once you get familiar with the system, it's actually pretty straightforward. You just need to memorize the rules. Let's go through, so just a few things to highlight. Remember that we put dashes here between, whenever you have a number and a letter next to each other, you put a dash in between. You always put commas between numbers. And if there's 2 words in a row, you just run them together. Elements and chemical names are not capitalized unless they're the beginning of a word, but they shouldn't be in capital case, so don't capitalize them unless there's a good reason to. Let's do one more practice, and then there'll be an additional video with practice opportunities. So press pause and try to give this a name. Okay, let's do this together. So our first step is to find the longest parent chain. And sometimes this takes a little bit of experimenting. So as I look on this side, I see that it looks like this is part of the longest chain. All right, and now I come to here and I see that I'm going to need to go up to stay in the longest chain. And what I might do now is count my carbons in the longest chain and then try some other options and make sure they're not longer. So I've got one carbon here, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is in fact my longest chain. All right, when you first start out, it's kind of handy to note the side groups and just name them separately before you put it all together. But before we do that, let's number. All right, so if we number from the left, this would be 1, this would be 2, and we hit a side group at 3. If we number from the right, this would be 1, this would be 2, whoop, and we hit a side group at 3. So it appears either way we hit a side group at 3. So what do? Well, this next carbon, carbon 4, if we go from the left, has a side chain. But carbon 4 from the other side doesn't have a side chain. So it's slightly preferable to start, in this case, from the left-hand side. Sorry, I'm going to fix that there. All right, let's go back to numbering. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's start putting a name on this. First of all, I know that the parent name is decane because there's 10. And let's start writing groups down. We've got at 3, we've got a methyl. At 3, we have another methyl. At 4, we have a methyl. And at 8, we have a methyl. So as we name this, we find we have 4 methyl groups and nothing else. So we're going to call this 3, 3, 4, 8 tetra methyl decane. If you're having problems with this, there's some more practice in the next video.